This is Amateur Logic, episode 187 for November 17th, 2023. Amateur Logic is brought to you by ICOM. Keep your competitive contesting edge with ICOM. Heard it, worked it, logged it. Good evening, I'm George.
I'm Emil.
And I'm Mike.
And Tommy is not with us tonight. He is on a plane traveling as we speak. Either that or he's sitting on a tarmac somewhere. It could go either way.
Likely.
Yep. So we've got a fun show lined up for you tonight. I think it's some good segments coming up. I'm going to be building a 4-to-1 Balun. You know, a few months back, I built a 1-to-1 and we showed it here. Now I've got the companion segment for that. It's building a 4-to-1. Emil, what are you going to be showing us tonight?
Absolutely nothing, George. I get to be the slacker.
You know, nobody lives up to that title like Emil does.
No, nobody lives it up as much as Emil does when it comes to slacking.
He takes it serious, man.
This is professional slackism.
Yeah, Mike, what are you going to have tonight?
Well, we're going to show you a power converter.
That's right. And I've seen the video, and yeah, it's good.
But it also has some exciting news.
Oh, it's here.
The rat. Oh, it's look at that. It's transparent.
Yeah.
Amazing. Yeah, the Raspberry Pi 5 arrived it arrived during the day, but picked it up last night at the mailbox.
Wow. Have you booted it yet? Probably not.
Everybody asked me that. I have not. I was thinking about it, but I didn't really have an image ready to put on it to fire it up. So the only thing I'd be looking at is that, what is it, that 4-color test screen that shows up when you first power up the Pi.
We'd even like to see that. But no, well, congratulations. How many gigs of RAM did you get in that one?
This one's a 4 gig, and that was expensive enough. So
yeah,
I got to thinking about that. I have my Raspberry Pi 4s, which I've yet to put to dedicated use. They only have 2 gig, and there's still plenty left over. So if you're not running an operating system like Windows on it, like if you're running Pi OS, 2 gigs is plenty.
Cool. We'll be looking to hear more about that. It's going to be, well, I'm waiting on mine. It said sometime in December or later, so who knows when it'll show up here. Tommy sent us a video for tonight, and it's going to be on a project he was working on, M5 ham radio. So you'll want to stick around for that, I'm sure. It's interesting stuff. Yep. So, Mike, this is not an email, but you have a post for tonight.
Microsoft has entered the microchip game and has built its own custom AI chips. They're calling it Microsoft Azure Maya AI chip. And there's an ARM-powered Azure Cobalt CPU. And they're arriving in 2024. And it basically is intended to lessen the demand. Of course, with all the Bitcoining and AI stuff that's going on, the NVIDIA chips are the hot item. So they decided to build their own. There's such a high demand for these GPUs that some have even fetched more than $400,000 on eBay.
Wow. That probably is hard to get as that Raspberry Pi 5 was.
Yeah, I don't think they're for the end user.
Yeah.
It's going to be interesting to see what they do with some of these custom AI designed chips for AI use, that is, in the next few years. It's exciting and scary at the same time.
Yeah. Well, we're going to look at Tommy's video now. Since he's not here, we'll go ahead and show it. I would like to have one of these myself. I have not clicked the order button yet, but I might have to.
I got a new little microprocessor. This is an M5 stack, a Core 2. One of the newer ones. I bought it back in May. I was going to show it to you. There's a cool project out there that we're going to do today on it that's going to pair this up with my IC705. It's got a lot of functionality. It's pretty easy to set up. Since I got this one, there's a Core 3 out. I'm not sure that it's supported by the software that I'm going to put on it yet, but if you decide to do this project, be warned that you probably want to at least get the Core 2 or even the Core, the original one. This is the AWS version. I got it on Amazon here for $49.90, I think it was, a while back, like I said. It's gone up to 70 something dollars now, but you can still get the non-AWS one for like $50 or less. And it'll work just fine. The only reason I got the Amazon Web Service one is because the others were out of stock and I was a little bit impatient, but I should have waited. It's the only one they had available at the time. I wanted to go ahead and do this segment, but I got tied up with some others. But anyway, let's dig in. The software is called M5 Ham Radio. It's supported by different radios. There's the 705, 7300, and the 9700. I'm going to show the 705 today because it's the most convenient, but I'll probably use it for my 9700 here at the house, because I have it behind me and I'm normally looking in the other direction while I'm working, and I'd like to have the display up there in front of me, so I might use it here for that too, but that'll be another story. So let's go ahead and get it set up. First of all, it has 4 utilities in here. It's got an ICS meter, as you can see. It's got the IC multimeter, which shows the S meter. Essentially, it emulates the front display of your radio. It's got an IC keyer, which I'm pretty excited about for field day. So if you use the keyer, you don't have to have the slots showing on the screen. You can show your regular waterfall, looking for contacts, and you can send your messages, your call sign, and so forth that you've got set up in these slots through this IC keyer wirelessly. And lastly, there's a DX tracker that shows the gray line and contacts that have been reported and so forth. So it's really cool stuff. Pretty easy to install. Let's go ahead and do it. First of all, we need to download the M5 burner right here. And there's the installation page. I've already done it, but I'm going to go ahead and show you where to get it from. Right here, M5 burner. And download the one for your OS. I downloaded the Windows 10 64-bit one. Now let's run that. So I'm going to go ahead and minimize this. And we will bring up the M5 burner. It's a pretty simple interface. My device that I told you is a Core 2. So I'm going to pick Core 2 and we'll search for M5 Ham Radio. There it is right there. So let's go ahead and download the firmware. Pretty fast. Done. And what we need to do is hook up our device to the to your computer, to the USB port. So I'll go ahead and plug it up. I think it's going to power up by itself. It does, and this is the default firmware on it. So let's go ahead and click burn, and it'll transfer down here. So what we're going to need to do is, yeah, it's unofficial. Yes, I want to continue. We're going to need to pick the COM port that this is hooked up to. Let's go look at Device Manager. Device Manager, Silicon Labs. I know it's not on my standard COM port, so it's the Silicon Labs one. You'll see that CP210 COM3, so that's the one we want to pick. So I've already got COM3 chosen, and I left the default rate alone. So let's go ahead and pick Start. Okay, it's at 100%, so give it a minute. Still working on it, trying to finalize, I guess. Doing a reset. Okay, it's done. We can disconnect it. It's going through the bootloader, and it failed to load the config file. So what we need to do now is put the config file on for a 705. I went ahead and made the config file. To get the default one, you can go over here to the GitHub page for M5 Ham Radio, and there'll be a link to this in the show notes, by the way. So I go actually down here. Here's the one I defaulted with, my IC705BT for Bluetooth INI file. So basically copy this to your clipboard and open it up in Notepad. Now I went ahead and did it just to save some time. And there's the default one right there. And I went ahead and put the ICOM device. One thing you're going to need to do is go into your 705. Go to Menu, Set, Bluetooth, and go down to Bluetooth device information. And you're going to need to get this MAC address and put the MAC address in your config file. This is essentially telling the M5 stack that your device is okay to connect to. So put that in there. You can see that's mine, the NC9C7A. Next thing, you need a micro SD card. I've got these little cheap 32 gig ones. I bought a whole bunch of them off of Amazon. The other thing you need to do is go ahead and put your location in here, your latitude and your longitude, and you can get that. I get it by going to my location right here, and it'll show up somewhere right here. So I basically just copied these and put them in the latitude and longitude places on that file. Again, that link will be in the show notes as well. The other thing, put your Wi-Fi information in your hotspot name and your password for 2.4 gigs Wi-Fi. This device does not connect to 5 gigs. So geolocation, that, your Wi-Fi info, and your MAC address for your ICOM device, and then your connection. I'm using Bluetooth. You can use USB, different things. So there's a USB connection. So you're gonna need to look through the documentation here if you've got something other than Bluetooth you want to use. Now I've got the files already on my micro SD card, so I'll put it in here. The reset button is on the bottom, so I'll hold that in. We'll reset. Bootloader is going. Oh, the INI loader. It's a little bit fickle to control. Okay, the left and right button go up or down. That's the one I want, so I'm gonna hit the middle button. It's loading up, doing bin loader. Sorry if I had a reflection on there. When it gets to INI loader, tap that middle button again, and it'll allow you to pick an INI file. Takes a few moments to load. INI loader, touch the middle button. It shows you the INI files that are on there. So I'm going to go down to the one that's got IC705Z and O, because that's the one that's got my custom settings on it. I didn't want to show you my password. And I'll hit the center button to load that. Loading it up. Oops. Sorry about the reflection. Needs to have a connection made. So let's set this down and go back in our Bluetooth connections. Bluetooth device information. Oops, we don't want device information. We want to pair. Pairing connect. Search for a data device. Keep your fingers crossed. If everything goes well, connection failed. Oh, but it didn't fail. It worked. Watch. Here we go. Now, shows everything on here that you see there pretty much, and some extra. Let's turn the radio some. Get the screw layer off of it. Okay, so that's one. Let's go, since it's paired, let's go ahead and reset again. And this time we'll load up a different app. So let's touch that. It's got DX Tracker. Let's take a look at that one. Reading the INI files and so forth. The INI file's got your GPS coordinates and your Wi-Fi connection in it. DX Tracker's coming up. It's got real-time data on it. How cool is that? And a little portable device like this. That is absolutely incredible. Let's see what else we got. When it starts loading, you need to hit the center button to allow you to pick the others. So let's go down. I want to do the keyer. Again, I'll go more into more details on these in a follow-up video, but just wanted to get it going for you and show you how it's pretty easy. The most frustrating part's getting it paired. It's not that bad. You just need to be a little bit persistent. Once it is paired, it seems to be very reliable, and I'll show you that in just a moment once this gear is up. Connected to our 705. You can see it right there, 705 Bluetooth. We're on lower sideband. We pick one of these. We can hit start and transmit number 6. We want to do number 1. We hit start, it'll transmit number 1, and so forth. So we've got eight memories there that we can transmit. I'll do another segment on setting those up and how to use it later. But at any rate, it's pretty neat. You can go to a menu and set your brightness, beep, shut it down, exit, and so forth. So let's go ahead and go back into the IC multimeter and show you that it connects back. We'll finish up. We should see it pair on here in just a moment automatically, because I have mine set to automatically repair, not repair, repair. There it is, IC multimeter connected. So once you go through the hassle one time, you're pretty much done. So let's see, there it is, and you can see as I tune here that the display is changing. Let's change the mode. Lower sideband, we'll just change it to AM for now. There it is, shows AM. Go back to lower sideband. Back to lower sideband. Pretty cool stuff. My 9700 is behind me, and I plan on setting this on my desk in front of me so I can see what's going on the radio behind me, not have to turn around. And I'll use it for my 705 when I'm on field day and doing things like that out in the field. The keyer is going to be really nice, so again, we'll play with that later. Anyway, I hope you find it useful. Check the show notes for the links to all these things. 73.
Email is not con compliant, but if you want one, you want one. You know, it's one of those.
I seem to remember a video of you with those people at the date, maybe.
Yeah. And I'm not sure if that's the same project or not that they had at Dayton. It may be, though. It sure looked, well, I know it's the same device. It may be the same software. Probably is. But that's a neat little device, man.
Yep.
Yeah, I was looking at something similar to that, and it's called a re-terminal. And basically, it's a man-to-machine interface. And that's what they're designed for, or originally they were designed for. But yeah, you can think of all kinds of uses for something like that. Pretty cool.
It is. You know, this is the point in the show where we would have an email from Tommy, and he's not here tonight. But as luck would have it, I have something from the actual mail here. Not an email, not a post, not a rumor.
Really?
Yep. It came in the mail. The 2024 ARRL calendar. And let me tell you this, if you need a calendar with all 12 months in it, this could be your ticket right here. It's got some nice pictures in it too, man. I haven't seen these before, but that's Hiram Percy Maxim's transmitter right there. His old Betsy spark gap.
Wow.
There's a motor.
Yeah.
Right there too.
Is that the key? That little copper strip?
No.
What is that?
That's just that's how he connects it. That's just a piece of copper strap. I guess this is a resonator.
There's no way I'd be touching an uninsulated copper strap like that with all hundreds of bolts on that thing.
I didn't even know they had LED lights back then, man. But you know. Here's his key right here, Mike.
Oh, wow.
Yes.
Whoa. It's a long throw.
It is. And you know, as a bonus.
You're looking at the shorting, what do they call that thing? For tuning up, it's like a knife switch. You put it down and it puts
yes.
That's on the right.
Yes, here's the button right here.
That's the key, yeah.
Oh, yeah. Wow.
Well, there's a spring in the background. It kind of makes it look like that.
But as a
2.5
bonus,
words a minute
look,
maximum speed.
check this out, man. They put an extra day in February.
Is it a leap year this year?
Yeah,
Oh.
sure is. And look, where'd that come from?
Comes from the remote.
Anyway, there's a lot of neat pictures in here from W1AW. That's in the ARRL 2024 calendar. That's basically what they are there. But some nice looking stuff if you want some wall art to go in your shack. Plus,
I couldn't help but notice though. You did notice that there were no antennas mounted on the roof, and I'm imagining Mrs. Maxim didn't permit any antenna installations on the house.
well, they could have been in an HOA, Mike. Yeah. Anyway, check it out. 2024 ARRL calendar. I actually like this one better than last year's. Some really interesting stuff in there. Well, on with the show. We're going to take a quick break, get a message from ICOM, and come right back. And I'm going to twist some wires together.
Keep your competitive contesting edge with ICOM. ICOM's high-power base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA1 app. Heard it, worked it, logged it. The IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution Spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. The IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The ICOM IC7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR. RF direct sampling system, 110 dB RMDR, independent dual receivers, and dual digicell. ICOM's IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing the generated inherent noise in different IF stages. This is a radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. For more information about ICOM's amateur offerings, visit icomamerica.com/lineup/amateur.
Man, this is a nice Balun. I'm still using it. It's hanging out here in a tree right now with my wires on it, unless the squirrels have got to my rope. They got to the rope on my loop. It's been up for years, and they've never bothered it, but finally they said, all right, this is the time, and they bit my loop rope, so it's on the ground. I've got to get out there this weekend and get that back up. But right now, let's look at a 4-to-1 Balun. On June 16th, in episode 182 of Amateur Logic, I showed you how to build a high-quality 1-to-1 Balun. This month, we'll be building a high-quality 4-to-1 Balun. It's a very similar construction process, but there are a few things that are different. We're using essentially the same materials for the 4-to-1 Balun with a couple of additions. First, we're using 2 toroids here. We'll still use 2.4-inch ones, number 31 mix this time around. We're still going to use the same high-temperature insulated magnet wire as we used before. However, this time we're going to cover it in Teflon insulation. The original 1-to-1 Balun we made, we had the 2 wires side by side. That gave us a 50-ohm transmission line, which we wrapped around a toroid. By adding the Teflon insulation around the wire, we're increasing the spacing, making this a 100-ohm transmission line. So we'll need to wind 2 100-ohm transmission lines, one around each of the toroids.
You may want to review Amateur Logic episode 182 for details on the 1-to-1 Balun. Much of that information will apply to this 4-to-1 Balun project too. As before, I have a chart here that's showing how many turns we're going to need. I'm going to build a 3 to 10 megahertz Balun, so we'll need 13 bifiller turns of sleeved number 14 wire on each of the toroids. So I prepared my wire in advance by scraping off the insulation and tinning it because it would be easier to do it when it's free like this. We'll slide the Teflon insulation over it now. We'll need to tape these two lines together every 1.5 inches using some of the glass fiber tape like we used last week. At one end of the windings here, we'll actually need to tape the wire itself to the tubing so that it doesn't slide in and out as we're working with it. And as before, we want to keep these as straight and parallel as possible. Now we've got both of our transmission lines ready to go here. We're going to wind the first toroid, leaving about 1.5 inches free on one end. And we're going to try to space these as tightly as we can. I'll put a tie wrap around the first end now to keep it from sliding. I've got both of the toroids wound. It's time to do some identification of the leads. We'll just take one in here and we'll mark it as 1. We'll find the other end of that particular wire. We'll mark that 2. And then back over here where we began, we'll mark the opposite wire 3. And then there's only one end left. We'll mark that 4. Now on the other toroid, we'll pick up with number 5. We'll find the other end of that wire. That'll be number 6. And then back on the end we began with, number 7. And then the last wire, number 8. We've got to connect all this together and stuff it in this box. So I'm going to begin, and I may end up redoing this, but I'm going to tie wrap the two toroids together, one on top of the other. Wires number 1 and 5 need to be connected together and go to the ground terminal of the SO239. Wires 3 and 7 are connected together and connect to the center pin here of the SO239. This is going to take a little experimenting to pull off. Now I've contorted those two around to where they will probably fit. Now we need to try to make the other wires reach. For wires number 4 and 6, I clipped them off and soldered them together right here to put the tubes in series. You could insulate that with something where it'll be positioned in here. It's not going to touch anything, so I'll just leave it alone. Then you bend all the other wires like this. Now, how do you know where to bend all these other wires? Well, it took a lot of fiddling around inside this box here to figure that out. But everything should be pretty close to the right positions now. What I'm going to have to do is shove this in the box, make all the connections, and solder everything together. Since my screws are going in from the inside here for my terminals for the antenna, I decided it's probably best to go ahead and put my crimp lugs in there now because I won't be able to get a screwdriver in there later. So let's see if we can get everything to fit. You know, this is probably actually going to work. Now you can see that I'm not going to be able to get my crimpers in there. I left the screw unscrewed a little bit. That's because I don't want to melt my plastic box here when I'm trying to solder on this connector. So we'll pull it back a little bit best we can. Now we'll flow some solder down in here to make that connection. All right, the next thing I'm going to do is connect the SO239 here. You can see I've got the one lug there that's kind of bent up looking. See if I can flatten it. It's going to go under the ground lug, but first I want to put a washer under there. Then we'll fit the terminal through, another washer, a lock washer, and then the nut. All right, that's good enough for temporary. We can see that our center pin lined up perfectly with the wire we intended to solder into it. So we'll just solder that now. Now we've got the SO239 about complete. We'll want to come back and
tighten up that screw and nut right there, but we'll leave it for the time being. We've only really got one connection left, and that's the one going to the opposite side of the antenna here. So we'll just bend our lead where it'll fit in that terminal. That looks good, and I'll just put my pliers behind there to kind of hold the terminal off the plastic because I don't really want to melt the plastic. And now let's see if we can flow some solder down in there. All our connections are made. Now it's just a matter of tightening up everything. I'll do the SO239 first. We'll get that good and tight, because if that ever gets loose, we're going to have a real problem. But I think we can get it tight enough, and especially with the lock washer on there. Might be wondering, how in the world are you going to get a screwdriver down in there? Well, I thought about that, and fortunately I came up with a solution. What I'm doing here is, when I drill the hole for the screw, it is so tight that the screw actually cut threads into the plastic here. That's good, because I wanted that, and to kind of help make it watertight as well. But how do you tighten it up? Well, I took 2 nuts and I stuck out here on the end of the screw. And we'll use a wrench to tighten the screw up with. And that feels like it. It's good and tight. So what I'll need to do now is take off the outer nut and then just screw the inner nut on down. And now we'll just do the same thing on the other side. And there we go. And we'll just kind of move the Balun around to where it's kind of centered in there and nothing's really touching that shouldn't. And now we've got 2 more eye bolts that we'll screw in through the sides here and put nuts on. These 2 are antenna leads from our dipole will actually tie around, and that'll kind of stress relief them, and the end can just loop on down and connect onto the wing nut. Now these I drilled with a smaller bit so the eye bolt would actually cut threads into the case. There's 2 reasons I did that. One is to act as a second nut, so when I put the nut in there it'll be held tight into place. And the other is to try to keep water from leaking around there. But there's another thing I'm going to do to try to keep the water out. I'm going to use a little bit of one of my favorite glues here. It's 3M Super Weather Strip Adhesive. I'm just going to put a little around the threads of the eye bolt. And we'll screw it on down, and hopefully a little of that is going into the threads and giving us a watertight seal. So there we go. One complete 4-to-1 Balun, heavy duty. All we need to do now is put the case on and check her out. Also, one thing you didn't see me do on this Balun, or the last one I built, is I used some of that 3M weather strip adhesive up under the SO239 here to act as a water seal on it as well. I want to thank Joe Zaleski, KC8LC, for providing the materials and the research to make this project possible. And Joe pointed out 2 resources that he likes that you should probably know about. The first is the book Reflections 3 by Walt Maxwell, W2DU. It was printed by CQ Communications, and it's got an excellent explanation of common mode current in Chapter 21. Also, K9YC has written many articles and done videos on the subject of controlling RF and RFI. He builds on Walt Maxwell's writings and presents the kind of information every ham should be aware of.
I got to ask you, George.
Yeah.
When I made my 4-to-1 Balun, the hardest part was winding that number 14 wire around the toroid, because you want to get it as tightly to the core as possible.
Mm-hmm.
And by the time I was done wounding, I swear my wrists hurt and my fingers hurt for probably a week after that.
Mine probably did too. It's been several years since I did that, so I don't remember now. I run near legal limit, so I haven't smoked it. It's hanging in there.
Well, if you look at I think it's high power Baluns.
Yeah.
If you look at their designs, they're very similar, and they're using the same gauge wire, the same dimension toroids, and they spec their Baluns for 5 kW.
Yeah. Oh yeah. I think it would probably do it.
Pretty neat trick with those double nuts and screw there, George.
Yes, that was a very necessary part of it. Otherwise, I was going to booger up the ends of the screw with a pair of pliers trying to tighten it in there. So, yeah, you use your tricks wherever you can.
No doubt.
Email. You've got, what is it? You didn't slack completely. You did come up with something to talk about this time.
I found a post from I don't know, some random guy on the Facebook forum. George, you might know him pretty good, I think.
Yeah.
But look out, the FCC has changed the rules. The 300 baud symbol rate is no longer. You probably know or remember that every time there's an emergency or something going on in the world and disaster response is needed, there's the ARRL used to petition them and put in a request for an exception while that was happening. Well, now it looks like they're changing that limit on the HF side from the 300 baud symbol rate to whatever will fit into 2.8K. And for us digital nerds, of course, that is news to our ears because, we're going to figure out how to shove as much as we can in that bandwidth and just, using all the published protocols and I'm sure compression or some other things that's whatever it's going to take to make it work for us. So you can see there the article on the right is the ARRL basically hailing the action and thank you for letting us continue to innovate and just figure out how much we can shove in that 2.8 kilohertz bandwidth.
Yeah, it was way past time for that because the technology has marched on, and
Yeah, it was probably stagnant for a while.
Oh yeah, that's an arbitrary limit. At the time they made that limit years ago. Yeah, I don't guess they really thought about, well, these guys are going to come up with a better way to get more data down there with less bandwidth. So, yeah.
There's already equipment doing it, of course, the P4 Dragons and some other things, but in the VARA, HF protocols and things, they're capable of it, but they always had to get that exception in place first.
Yep. Well,
so
it's thanks FCC for doing that. Well, Mike, you had a project here this time around that really piqued my interest. I like this. You want to set it up?
Sure. I mean, this is not a new thing, but I came across these little boards, and what it is, it's a voltage converter, but it's both a boost and a buck converter together, kind of like a buck boost converter, but it's a little different in design in the sense that it doesn't invert the output. And normally that happens when you do that with an inverter power supply. The output is inverted, but in this case it's not. So it's a single-ended output. And I thought, one of these little things might be ideal for portable use.
Buck, boost, and buck boost converters. One of the challenges when operating portable is a stable power source. When operating on battery, the voltage will start to decrease over time. Most amateur radios are spec'd to operate at 13.8 volts, but will operate on lower voltages at reduced power. Here is a graph of the state of charge for a typical 12-volt lead-acid battery. You can see that the voltage begins to drop off even before the battery is discharged. The voltage is down to 12.5 volts, although it's only 50% discharged. You can see here that the lithium batteries retain a stable voltage longer, but drop off sharply once they are discharged to about 65%. What you can do to extend your operating time is to use a voltage converter. There are three major types of voltage converters, but mainly we are looking to boost the battery voltage. There are commercially available battery voltage boosters as shown and work well, but consider the following. In addition to ham radio outlets, converters are available at Toshi Station. Who knew? As mentioned, there are 3 types of voltage converters: buck, boost, and buck boost. I'll be focusing on a special type of buck boost converter called a SEPIC converter. A SEPIC converter differs slightly from a buck boost converter in that it produces a single-ended rather than an inverted output voltage. As their names imply, a buck converter maintains a constant output voltage when the input voltage is higher, much like regulated power supplies do. However, a boost converter increases the output voltage at a reduced current from its input. A buck boost combines both of these functions. A SEPIC, single-ended primary inductor converter. The following slides detail the operation of a SEPIC converter and how it works. This information can be found on its own Wikipedia page.
Warning, warning, warning!
This project involves power conversion. Be sure that you know what you are doing before connecting it to your equipment. Test everything before connecting. I found these interesting and inexpensive SEPIC converters. Costs ranging from $10 to $18. They're certainly COM compliant, so I decided to order and try one out. Looking at the device specifications, it will certainly fit my application. My QRP rig's maximum current draw is 3 amps. This one can manage 10 amps, or so the specs say, with heat sinks, or up to 8 amps without. At 3 amps, this little board shouldn't even break a sweat. Please note that similarly to linear voltage regulators, there are other factors to consider such as input-output differential, which greatly impacts on the power dissipation. So bear this in mind when choosing your particular application, as your mileage may vary. The heat sinks come pre-installed. This unit is fused at 15 amps, so I'm guessing it's there for fire protection rather than protecting itself. There are 2 LEDs on the board. Fault illuminates when the output voltage is set below the under voltage setting. The output LED illuminates whenever the device is outputting power, regardless of what it may be. There are 3 miniature multi-term potentiometers that adjust the low voltage cutout, constant current for driving LEDs, and output voltage. At the heart of this SEPIC converter is a Linear Technologies LTC 3780. I was concerned about protecting the printed circuit board from damage and accidental shorts, so I designed this 3D printable enclosure. I used Tinkercad, which is a free online 3D design program from Autodesk. The bottom of the case includes 4 mounting studs to permit the attachment of the SEPIC PCB with mounting screws. The top of the case has 4 internal small tabs, which fit into 4 recesses in the outside of the case bottom. There are holes in each side to permit cable entry and attachment to the input and output terminals. As an unplanned feature, when the top case is snapped shut on the case bottom, the SEPIC PCB is securely held in place without the need of mounting screws. No rattling. For the following adjustments, you require 2 voltmeters, basically anything that will accurately measure low voltage DC. A voltage source such as a low voltage variable DC power supply works well for this. In this slide, you can see that my input voltage is 12.5 volts DC. The fault LED is illuminated, so there's no output power. This condition indicates that our low voltage cutout adjustment is set too high. After I lowered the low voltage cutout adjustment, the fault LED turned off. The output power LED illuminated, and I could now adjust the output voltage. It works! I'm now getting 13.6 volts out with only 12.5 volts DC in. As a rule, whenever I'm using switch mode power, I place a ferrite bead on the output voltage lines. Final thoughts. I will need to do some field testing to determine if noise from the SEPIC converter is an issue. A shielded enclosure may be needed. Well, that's all for now. 7.3 from VE3MIC.
Mike, I'm really looking forward to a follow-up report on that and how it actually works out in the field. If you seem to get more life out of your batteries and if it's noisy or not, and just all the details of actual ham using this thing.
I have a lot of batteries, and the if the batteries have been sitting for a while, I'm talking about sealed lead acid batteries, they're usually down to about, I don't know, 12.2 to 12.5 volts. And yeah, you could charge them up and then wait a few days, and then you're going to find that voltage is back down again, even though you brought it up to 13 point or 12.6 rather. You're going to find it's back down. So I thought this might be a good way to deal with that and not have to worry about running to the site immediately after unplugging it from the charger. So
Yeah.
I'm interested to see what the noise is. Like any type of inverter technology, there's going to be noise generated. How much noise is yet to be seen. I haven't been able to get everybody out of the house. Otherwise, I would have tried turning all the power off in the house and then hooking it up with just battery power and doing some testing here at home. But I'm going to have to probably wait until it's a nice day and I can get out to a park or something.
Yeah. Well, like I say, I want a full report on that. I don't know, email. Look, well, I don't really run QRP that much, but but still,
Ever.
yeah. That looks like the perfect device. I know Tommy's probably going to be looking into that as well now once he watches this.
Winter field days coming up, Mike.
Yep.
Woohoo! I don't have to worry about mosquitoes. Of course, there'll be 2 feet of snow on the ground and sub-zero temperatures to contend with, but
No mosquitoes.
You'll be out there doing
mosquitoes.
antenna work anyway. So.
Well, yeah, that's a given.
It's good antenna weather.
In fact, cousin Jerry was mentioning that the other day. He says, "Oh, you still got time."
Yeah.
Of course, he's living in the banana belt of Canada, about as far south as you can get in the country, and of course, his winters are a lot more milder than what we get up here, and of course, the temperatures are warmer as well.
Yeah. Well, this is an actual email. It didn't come in the post mail, but it came as bits to me from one of our friends. I hadn't noticed if he's in the chat room tonight or not. I don't think he is. Maybe. Elliot sent me this. WA1ONF. And, Elliot sends us an email ever so often. This time he sent one with some pictures that were very nostalgic to me. And you guys, I'm sure some of the folks watching, may recognize some of this gear right here. The first one, well, it would have been one of my favorites. I didn't have this exact model. I had a previous model of it. He said this was a real top-of-the-line meter in its day for Radio Shack. And yes, you're right. I think that's the best analog meter they ever had. That's the FETVOM. I had an earlier model of this that the case didn't have rounded corners, sort of reminiscent of a Simpson 260 like this one does. They were squared off corners, and I dropped mine one too many times, and it finally I couldn't recover it anymore. It damaged the movement in it, but I had it for years. You'll see it in some earlier episodes of AmateurLogic where I used it a lot. Personally, although I've got a nice 260, I preferred this meter to the 260 because of the high input impedance on it. It's just a very nice little meter. I really like it. Do you remember these, Mike?
As a matter of fact, I do. And as a matter of fact, I happen to own one.
Ah, there you go. And what's...
Yeah, the good old 22-220.
Yep. Recommended?
Dual fed input. We can't call it a VTVM. I guess it just an analog voltmeter or a multimeter rather.
FETVOM.
Yes.
Yeah. So yeah, real nice. And another piece of test equipment he sent along here is an RCA transistor tester. I don't remember if I ever saw one of these, but I did see one of these other RCA instruments he's talking about. It's the Master Voltomist. They used those in his high school days in the AV department, and the AV instructor passed them on to him at graduation, both of those RCA meters. We had this in school. I think we had at least one of those in college. We had a lot of Syncor analog meters back in those days when I went, but there was one of these there, and have seen these at various places. They were probably like one of the earliest, best high impedance meters for working on transistor circuits and stuff. You could go in there and measure without loading down the circuit and changing how it operated. Either one of you ever seen one of those?
Just in pictures. I've never seen one in the wild.
Yeah.
Yeah, not that model. Not me.
When I was at college, we had these. Well, I don't see Terry or Nigel in the chat room, but they'd likely recall this particular model. We had AV08s. They were a analog multimeter, and I think they were made in the UK, or they're definitely British design anyway.
Cool.
That's what we had. We didn't have anything like a Simpson.
So you had a metricon meter? Is that what you're saying?
No, actually, it would have been the old British standard. So I don't know how that works out.
Yeah.
It's a good thing we're not measuring, say, imperial gallons versus U.S. gallons, because there would be a discrepancy there.
Well, next month is, of course, December, and that's going to be our annual Christmas episode coming up. Let's see if I can guess what date that is going to be. Well, that's Halloween, Emil. That's last month. I don't know. It's probably going to be December 15th, but we'll have to see what everyone's got going on, and we'll, of course, post it at all the usual places. There will be a Ham College coming up. Well, it won't be November. It'll probably be December 1st. But, well, I'll talk to Tommy, and we'll determine that. And let everyone know.
Extravaganza this year?
Pardon me?
New Year's extravaganza this year?
I don't know.
Any thoughts about that?
We haven't talked much about that yet, so we'll have to see what everybody thinks about that. Maybe. I just don't know at this point. We didn't do one last year, but we did for several years in a row there. But I don't know. We'll get through. I guess we'll get through Christmas first, and it'll be a last minute thing like it always is.
Oh yeah.
Yeah.
It always is. It's a busy time of the year.
Oh, it is. Yeah, we've still got a lot of work to do before that Christmas episode, but I believe there are going to be some special offers this year, maybe.
There will be. I think it's going to be more of a, you know how the state of the economy is. Your dollar doesn't go as far, and, big box stores are cutting down on their inventory, and I think we're going to have to follow suit. And we're going to have to really limit inventory this year, and probably go with maybe a stocking stuffer guide. Keep the prices low, stay away from the big ticket items, and that way, make it more affordable to the folks.
Okay.
Speaking my language, mate.
It'll be interesting to see what we come up with.
But George, I'm a little scared that he even used the terms cutting down. So I'm going to go ahead and notify our lawyers ahead of time.
I noticed you were on the hotline there on the bat phone. So, yeah. Mike, what is that building behind you?
I don't know. There was a little bit of an Easter egg in my segment tonight. And keen-eyed Star Wars fans would get this. And obviously, I don't think Emil got it, being that he's a Star Trek fan. But
Star Trek.
Behind me is Tosche Station.
Oh, I definitely got it from your segment.
Ah, okay.
So there's a reference in the original Star Wars where Luke is complaining to his Uncle Owen that he wanted to go into Tosche Station to get some power converters. And there was a meme that was put out by Mark Hamill, months ago, where he's standing in front of a gas station, and the gas station happens to be Tosche. So, and he's got like a one of those looks like one of those car inverters in his hand, and he says, "After all this time, I finally made it to Tashi Station."
Nerds.
Yep. We got Thanksgiving coming up here next week. Mike, y'all have a holiday up there as well, but
Yeah,
I don't know the date.
Well, we don't have a holiday on Friday, although, close ties with Canada and the U.S. I work with a number of fellas that are from the U.S., so yeah, they celebrate Turkey Day, and any excuse to have more turkey, I'll celebrate that day too. So we had our Thanksgiving in October, and I think it's probably better that we do, because usually the weather is pretty nasty up here on your Thanksgiving Day weekend.
Yeah. Yeah. Well, it's actually, I think it's going to be cool here. It's going to cool down next week after some storms. So we're looking forward to it. Though always good to have some time off. I'm taking off next week. I think Tommy's taking off as well himself. But, Emil, the relationship between the United States and Canada is sort of like the relationship between the United States and New Orleans. It's like the neighbor you'd go hang out in the backyard and drink a beer with.
That's right. We got the country in New Orleans. We got some French influences here, and they got it up there, and yeah.
Yeah.
Go ahead and tell them the history, Emil.
If you're looking for something to do this Tuesday night, and let's face it, who among us is not, you might want to check out the Logic Net. That happens once a month. It used to be the AmateurLogic Soundcheck Net. We did every Tuesday night, but now it's once a month. Tom Apple Linux picked up the net and is running with it, and they're going to be here this coming Tuesday night. We got a lot of different digital modes you can connect with, as well as Echolink and All-Star. So join us Tuesday night, 8 o'clock Central Standard Time, 0200 UTC. And get in on the net. Good group of guys and girls that hang out in there as well. Emil, any final thoughts before we get out of here tonight?
Always, if it works, right?
Well, it didn't this time.
Maybe not. Eric, wait. Hold on. I'm gonna get it. There you go. Be sure to keep it cheap.
He's so cheap, he didn't even turn the lights on there, Mike.
No, I didn't pay my bill for the switcher, apparently.
Oh, okay. Mike, any final thoughts from the Great White North?
Get your Raspberry Pi 5s. They're in stock.
I'm on the waiting list. Looking forward to it. Tommy will be back with us next month. Happy Thanksgiving, everyone. Join us next
Turkey
month.
Day.
That's Happy Thanksgiving.
7-3.
Look, there's my turkey.
7-3. Well, you know how the state of the comedy, comedy, yeah, it is a comedy. The state of the economy is, or economy rather. Geez, I hope you can edit that out.